Hello everyone, and welcome back to a not so fun video, because I broke my good 260. So this right here is the GTX 260, the red one from Gainward, though I'm gonna be referring to it as Palette from now on, because Palette's like the parent company and I don't like saying Palette / Gainward all the time, because those cards are the same. Anyway, this is said to be the best 260 PCB that you can get by people who have a lot of good scores, so I tend to believe them. And this is also my only current example of this PCB. All the other 260s I have are different PCBs. Yeah, so this is the card where I made my current water cooling score on HWBot. And the only thing that I really don't like about this card is that it has Samsung memory chips. Because a lot of people say that you want Hynix on 260s. Now, right now, I don't see a huge difference between Hynix and Samsung. You do need to mod the Samsung chips to be as good as Hynix, but you can do it. But I have a feeling that once we go to Sub-Zero, the Samsung chips might just drop off and be a lot worse. So that's like the only problem. At ambient, these ones are actually kind of decent. It's so it's Samsung HDI 512 Mbit, and it's the HJ08 bin. So that means that these are rated for is this the 2400 megabits bin? I think this is the 2400 megabits bin. So 2400 megabits means 1200 megahertz, which is what these are just rated at stock. Now the card doesn't actually ship at that clock, it ships below that, and I think the specific one ships at 1.1 gigahertz. But technically the chips are rated for 1.2, and if they can do 1.2, they can probably also do 1.3 for, like, you know, overclocking runs, which they actually don't. They needed mods to do 1.3, but they can do 1.3. Actually 1.33 is where I ended up on this card before it broke. So yeah, they're good. Then again, Hynix chips do 1320 and or above, just like that. Like, you don't need to mod the Hynix cards. I did need to mod quite a few things on this card to get the memory that high. But yeah. So I spent some time yesterday redoing this card, because this is version 4 of this card. And so, like, all the mods are on the back. And version 4 is kind of a complete rebuild of the card, because I removed everything except the multi-layer ceramics. Like, everything else, the volt mods, the can type caps, all of it was removed. Because, like, version 1 was just like, you know, stack some extra caps on the output, like here. Then version 2 was like, what about we do even more caps on the memory and the core this time? And then version 3 and 4 were like even more caps and also multi-layer ceramics added to everything. And at that point I had so many caps, like this right here. So, like, all of these caps are reused, and this is what I had over. Like, all of these caps were at some point soldered to the card. Like, it had way too many caps on it, and it was awful to, like, move it around, because no matter how you put it down, you probably would risk breaking off at least one capacitor. And then there's also the part where, like, it didn't really help. Like, can types are fine for, like, stacking them on the bulk on the output, and then, like, have maybe like one like this for on the far end of your memory power plane, because the VRM is here and then the last chip is here, and it's kind of a long way, so this one just keeps the voltage high. Yeah, and after that you just kind of want to, like, have multi-layer ceramics, like here around the core, or like on the memory chips, and then also input capacitors like these, because I've seen on my 1060 that modding the input can actually help quite a lot as well. So yeah, so, like, instead of, like, putting even more caps on, I just took everything off and just redid everything from scratch. And, like, right now the card actually looks pretty good. Like, that's a good looking mod, if you ask me. Too bad that the card never ran in this state. So yeah, I modded everything, and everything was fine. Like, just the day before I modded this card, which is my Sparkle card. This is the card I did the Volt modding video on. As you can see, the Volt mods have now changed to being EVC compatible. And it's also gotten capacitors and also input caps. No multi-layer ceramics yet, that's next. And also thermal tape the heatsink on, even though it doesn't cover everything. But yeah, like this is what I did my ambient score with. Because this card was currently in the process of getting cleaned all the flux off it and redone, so I did my air score on this, and this card also turns out to actually be a pretty good one. Now it's my best one, because this one's dead. So yeah, I guess going forward I'm gonna use this blue Sparkle card, or I'm just gonna get another palette. Which I still want this PCB with Hynix chips, so I might just keep buying palette cards until I get one with Hynix and then just sell the rest, or like keep the best one and sell the rest. But anyway, so I did my mods on this card, just like I did on the Sparkle card. Like, that one went fine. I actually haven't tested that card fully yet, but, you know, just like, yeah, I did my usual capacitor soldering. I didn't really record it because I kind of forgot. People keep asking for like cap modding videos, and I just always forget to record it when I work on it. But yeah, like, soldering-wise, everything's fine. Everything on the card was fine. And then I put the card back together, and I put it in the system, turned it on, and I saw smoke. I'm not entirely sure where the smoke came from, but I have a feeling it came from this screw hole right here, because that about-ish is the area where I saw the smoke coming from. And if you look at the copper right here, it looks a little bit burned. Like, just a little bit. I can't really show it that well, but this looks a bit like it burned. Like, you see, like, this is what a normal screw hole looks like. And this is just kind of like in this area where, like, something dug into it, even though, like, you know, I didn't use anything in that area that could dig into the PCB. Like, you can see the traces around it are all fine. So, something here smoked, which is weird, because the screw hole is just ground. Like, why would my ground power plant just suddenly catch fire, and only in this one place? Yeah, so I now have a pretty good theory as to what happened, but I'm still not entirely sure why that something killed the card. So, to get better mounting pressure on the card, I used a retention bracket that you saw in the other... I don't have it right here right now, so I can't really show it. But I used a retention bracket on the blue Sparkle card when I tested how to make the air cooler the most effective. And on the Sparkle card it was fine. But on this card, the bracket was touching this end of this capacitor right here. Now it did that on the Sparkle card too, on a different capacitor, somewhere in this area. And I did check the bracket is conductive. So now you can probably guess what happened. On the Sparkle card, there wasn't an issue with touching that capacitor because it was the ground side. So I just assumed that that's also the ground side, especially because the card like this actually comes with another bracket, stock, and I had that bracket installed, also touching this capacitor, and it was fine. So I just assumed that this is the ground side, and just put it on, and it was just like, well, ground is touching ground, it's fine. So that side is not ground, and the reason why it didn't catch fire before is you see how these other screw holes, like the bracket that the card comes with, use the inner holes, whereas everything else uses the outer holes. And the inner holes, like, are shielded. There's nothing conductive there. So when I used the other bracket before, the bracket was actually connected to vCore, because that's what the side of this cap is. Yeah, it's not memory, it's vCore actually. So the bracket was connected to vCore, that means the heatsink was also connected to vCore, and for some reason, it never shorted out against anything. Like, just touching the base plate that this card comes with in one place would immediately cause the short circuit. It didn't. It was fine. So that's incredibly lucky, which turned out to actually be incredibly unlucky because it caused me to just assume that this is the ground side and the bracket can touch that just fine. So I connected the bracket, turned it on, vCore turned on, vCore was shorted to ground, and apparently in this area the contact was good enough or just bad enough so that it started burning here. It could have started burning in any of the other locations too, but it started burning here. So, vCore got shorted to ground. Usually not really a big problem. If you short something to ground, just nothing really happens except it might smoke a little, which is exactly what I saw. However, once I removed the heatsink and found out that, oh damn, the card was dead. No longer gets detected by the motherboard, like my motherboard has a little LED that shows if something's installed in a PCIe slot, that LED was no longer lighting up. So the card couldn't just display, it was no longer recognized by the system, which is really bad. So I began checking and diagnosing the card, and curiously enough, vCore is fine. The VRM that was shorted is fine. This thing runs. Everything in this side of the PCB is fine. The problem is that this doesn't run anymore. vMem is now dead, and I have no idea why. So it could be a completely unrelated failure that just occurred at the same time for random chance, but vMem no longer turns on. And the only way to fix this card is potentially to e-power it, which I'm not looking forward to because, like, I have an ample, but e-powering this is just gonna be very annoying, and I kinda don't wanna do it. And I have my Sparkle card, which is basically just as good. So, like, I really don't wanna e-power the memory, because that's like, if you can not e-power a memory rail, you probably should. I've heard from multiple people, if they e-power a memory rail, even they do like everything right, like the connections are solid, their memory chips just clock like ass. So, like, whenever I have the chance to not e-power a memory rail while I'm e-powering something like the core, I wanna try leaving memory stock. And now I have to e-power that exact thing to make this card work again. Why? We'll get into later. By the way, everything down here was still working, so this is the 5-foot rail that was working. This right here was not working, but that's because this uses memory as its input, so if that doesn't run, this doesn't run. And then on the back here, that thing was also running. It was outputting like 4.7 volts or something. Like, it's taking 3.3 volts and 12 volts on one side, and then in the middle it has 4.7. Don't know what it's for, but it runs. And this right here, I don't know what that's supposed to output, but I did check, and the vMem output is the input for this one, so that doesn't run, because that doesn't run. And yeah, so I went to the vMem controller. By this time I was already questioning, like, why does something getting shorted to ground here kill this completely unrelated thing here? I have no idea. Anyway, I checked the controller. Is it getting pulled low? No, the disable pin was at 2.6 volts and the disable threshold is 0.4, so that was not getting pulled low. Is it getting the VCC? Yeah, VCC 12 pin gets 12 volts. And I'm just like, well, all the other pins on the controller are just for, like, controlling the VRM. There's no other, like, thing that can disable it or something that needs power. The thing is getting power, it's not getting disabled, but the VRM doesn't run. So my conclusion then is that somehow this controller must have died, because it's getting everything it needs to control memory, but it doesn't control memory, or memory voltage more like. So this thing's probably dead. So this is an RT9259, I think. Yeah, RT9259A. So I have a datasheet for that, which is how I found the pins. Problem is, I don't have any other card that uses this that I could salvage it off. I have some cards that use something that's probably pin compatible, but, like, I still need those cards. And I don't know, like, if I can find for, like... The thing is, I can get one of these cards for like 10 euros. Even if the replacement controller, it costs 1 euro. Like, even just the chance of having it still not work if I replace this controller is just like, why don't you just buy a second card? Because like this card is decent, it's good, but it's not like amazing or anything. Like the core's about on par with the Sparkle card, and the memory, well, did exactly the same as the Sparkle card until I modded it. So I already have a card that's as good. And I really wanted Hynix on this PCB anyway, so it's just like, why don't you just buy a second card? And that's probably what's gonna happen. I'm probably gonna just, like, even though this is very repairable, I just don't really think it's worth. Like, if I ever get one of those controllers through something, I'll probably try swapping it out, and maybe I'll have another working 260, but yeah, it's... yeah, just... if it's just a year... I'll look if I can find a replacement controller for this and order it. It's probably gonna come from China and take like 2 months to be here by the time the comp is probably over. Yeah, but so as it stands, I think this thing is dead, but I don't have a replacement. So the card is probably entire. Like, I could also just e-power it, but I really don't want to. I just really don't want to e-power the memory. That's like the one thing I don't want to do. I might still end up doing it, but right now I don't have that much free time and or motivation for this. I really don't want to e-power the memory. So, yeah, the card is probably dead. Like, it is repairable, but I'm not okay with the things needed to repair it. Other than maybe ordering that controller and swapping it out and seeing what happens. Yeah. So, I still don't know why V-Core getting shorted to ground kills this. I have no idea. But that's what happens, got shorted to ground after that this didn't turn on anymore. Like, it could be coincidental, but it probably isn't. And yeah. And also the one thing I've learned is I have no idea how this thing gets power. Because this thing still got hot. Like, does this just run off 3.3 volts or something? Or does this just run off V-Core? Because, like, where is the PEX rail on this thing? It's probably that. Like, actually, it's probably... yeah. Yeah, that's probably the PEX rails. Like, that's actually a MOSFET, not an LDO. Which is interesting. I have no idea how to control PEX on this, actually. I just remember. Maybe that is why this card is so good at overclocking, because this, like, if this is a MOSFET, it's basically just a resistor. And it uses memory voltage as input, so if you raise the memory voltage, this goes up as well. So basically you raise memory voltage and the PEX rail also gets overvolted on this card. Maybe that's why these overclock so well, because people just don't do PEX rail mods? I have no idea, because, like, if you look at the Sparkle card, it has an inductor there. This doesn't. This is just a MOSFET. There's nothing on the back. Like, that's just a MOSFET. Like, every other card I've tested, like, there's an inductor. Like, that's probably that 5-volt LDO, and then there's an inductor here, and then there's, like, a little chip there. Which is, like, probably a little one-chip buck converter. So... yeah. I'm rambling on a lot now. But yeah, like, I still have no idea where this thing gets power from, because, like, that's 5 volts, that's PEX, that's an EEPROM, that's the temperature measurement chip, that's also an EEPROM, that's an AND gate, and that's all the chips. Like, unless this just uses some other rail to power itself, that's everything. Like, there's nothing on the back except for this thing, which is like a 4.7 volt regulator. Like, yeah. So, I guess that's it for the video. So yeah, I somehow managed to kill this card. Like, technically putting the bracket there is my fault, but I have no idea how that actually managed to kill this. Like, why only specifically this? Everything else still runs. Well, except that, because it uses that as input, but, you know. I don't know. I don't know. the card is a goner, like basically still fixable, but in my opinion not really worth fixing right now. So unless I magically figure out how to fix it, in which case there will be another video, I'm gonna use this card. I'm gonna do the multi-layer ceramic mods on this card as well, probably wire up a Volt mod for PEX as well, and then this will just be my go-to card now, because I've tested the other cards as well. The Asus card just sucks, at everything. It's just bad. The Zotac card is only a test card because it's a 192 core. And then the Gigabyte card, the Gigabyte card is a bit special because the core on it is a bit weak. It's not bad, but just measurably weaker than this and the palette. But the Gigabyte card is on Hynix chips, and it's my only card on Hynix chips. So I'm keeping the Gigabyte in the race, even though like the V-Core VRM needs a VID mod to overvolt and the core is not that great. I'm just keeping the Gigabyte because if I end up needing Hynix chips, that's my only Hynix card. So yeah. So like, that's just my go-to card now. Like, it's basically ready to go except for like cap modding memory chips and behind the core. And you can see here what I did to prevent any more short circuit scenarios, because like those two capacitors were touching the bracket as well. Now on this card, the ground side was touching, but I'm just gonna like put a piece of tape over anything that might interfere with the bracket now, so that I don't lose any more cards. That's basically the strat. And yeah, so yeah, you're gonna be seeing a blue card now instead of a red one. Unless, of course, I buy another red one, which is I'll probably do, because they're super cheap. But yeah, video's long enough now. I think we can end it here. So yeah, I killed a card. Don't know what happened, but it's dead. And until next time, goodbye.